see what we got here. Should be a nice medium. Alright, count number of trapezoids, part 1. We're given 2D integer array points where point set I is a coordinate xi. In the Cartesian plane, a horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides parallel to the x-axis, i.e. parallel. Okay, yeah. Two lines are parallel if and only if they have the same slope. Return the number of unique horizontal trapezoids that can be formed by choosing any 4 distinct points from points. Since the answer may be very large, return it modulo 10 to the 9 plus 7. Okay, so it needs to be horizontal trapezoid. So it needs to have a slope of 0 for the top and bottom sides. Okay, this should be fairly straightforward. I think it's going to be, I guess I could count the number of horizontal sides that can be formed. And since these are integers, the y coordinate for the side is going to be the differentiator, maybe in addition to the side length. So maybe for each y coordinate, I see the number of horizontal sides that can be formed from it. So like if it goes from 0, 1 to 0, 2, and maybe there's another one from, let's say there was another point that was, actually that's backwards. If there was 3 points that were like 1, 0, 2, 0, and 3, 0, so 1, 2, and 3, then of those 3 points you can form 3 horizontal sides at this y coordinate of 0, so like 1 to 2, 2 to 3, or 1 to 3. And then any of those horizontal sides can form with any horizontal sides that are at a different y coordinate, and that would form the trapezoid. Oh wait, has to be the same length, right? Otherwise it's does it have to be the same length? Trapezoid. This is yeah, okay, yeah, it does have to be the same length. My geometry failed me just there. Okay, so any horizontal side of one y coordinate can be formed with any horizontal side at any other y coordinate. So I'll just go through every y coordinate maybe. I think I want to sort. I'm going to sort based on the y coordinate. Do I need to sort actually? I think for every point, I keep a count of the number of unique x coordinates for that point. So for every y coordinate, count the number of unique x coordinates that pair with it. So for instance, if I have 1, 2, and 3, 2, that means y coordinate of 2 has lists of 1, 3. That use that list or the length to derive number of sides, horizontal sides, that can be formed at that y coordinate. And then okay, I'll do that first. Here it's the range of the y coordinates up to 10 to the 5th. I guess I'll probably use the default dictionary. No, actually, so that's the length of the number of points. So yeah, I think I use default dictionary here. So for every y coordinate, so let's say x list is going to be a default dictionary of, I guess I don't even need, I don't need a list. Actually, I just need to count. All points are distinct. So the y coordinate is 2 has a count of 2. So default dictionary is int for every point x, y, and points x, I guess this should be x count. And this is going to be, the key for this dictionary is the y coordinate. And then the value is the count of x coordinates with that y. Count of x with that y. So x count for this y coordinate is incremented. And then I go through and find the number of the side counts for each side count is going to be actually yeah, side counts is going to be a list for every y coordinate e in x count dictionary. I'm going to go ahead, so this is going to be number of horizontal sides generated at each y coordinate. So like if there's two x coordinates at a particular y, that means there's 2 points that can be generated to perform horizontal. So that's going to generate a 1 here. If there's only one x coordinate to a particular y coordinate, then that means you can't form a horizontal in that y coordinate. So that means it's a 0. I'll ignore zeros. So I think this should be, otherwise it's going to be like n times n plus 1 over 2, I think. Like if there's 3, then you can form 3 plus 4, 3 times 4 over 2. No. N times n minus 1 over 2. 3 times 2 over 2. Okay, so say the count is equal to x count for this y coordinate. And then if the count is greater than 1, then sides should be equal to count times count minus 1 all over 2 side counts. Append this number of sides. Okay, so then I have that, and then I need to use these counts at those y coordinates to generate trapezoids. And I think I want to use a prefix sum here. So let's say there's side counts that are um, 3, 4, and 5. So that means at 3 unique y coordinates, 3 horizontal, 3, 4, and 5 horizontal sides can be generated. So then I'll go through here and say that each of the 4 sides at this y coordinate is going to combine with any of the 3 here, and each of the 5 here is going to combine with any of the 7 here, and the 3 can make it more. So let's say I have a total of 0. So for every count and side counts, then that thing is going to multiply with any of the preceding values, preceding total, in order to generate the trapezoid. I do need to use mod here. So I think I also need to have an answer. So first off, the answer is increased. Answer equals answer plus the current count times the total before mod and then the total is increased by the current count. I think that's right. Side counts is misspelled, looks like. Side counts, not side counts. Okay. Alright, 70%. Can go faster somehow. So I have my dictionary. Okay. I think maybe I could combine these two in the same for loop actually. Because I'm generating the side counts here, but then I only use it once as I pass through here. So I guess I can keep the running total here. Answer equals 0 here. Everything moves up here. So I'm going to try avoid using side counts. So the count is this. If the count is 1, skip it. Wait. How did my answer go correctly with this actually? If the count is 1, no, this is the count of, this is the number of points, right? Yeah, this is the number of points actually. Yeah. Alright, I gotta tidy this up. This should be x counts. This is the count of x's at this y. And then the x count itself is from the x counts at this level. If that x count is 1, then skip it, because then you can generate 0 sides. And at that point, say sides that can be generated at this level is equal to the x count times x count minus 1 divided by 2. And then those sides multiply with the total. Answer equals answer plus sides at this level times total before mod, and then total is implemented by the sides here. And then just return the answer here. Alright, let's see if that works. X count variable is not accessible. Should I relabel this X counts? Did I return answer equals answer sides times total? Interesting, this doesn't work. Odd. Print sides. X count and sides, I guess. Doesn't get that far. Did I return? X counts as default dictionary. And then over Y coordinate. So it's not looping here. If X count is greater than 1. Oh, this is wrong. If X count is equal to 1, continue. Yeah, that's just wrong logic. Difficult. I think I can get rid of that. Get rid of that. Get rid of that. Alright, let's see how this goes without generating the other array. Still not fast. Okay, let's go ahead and reconsider this. So I have a default dictionary, X counts. I guess I could sort it rather than generate default dictionary. Should be pretty darn fast to do a default dictionary, right? Is it faster than sorting it? Alright, I'm gonna try sorting it to see if that works. Because sorting it would still generate my ability to determine the number of points at a particular Y coordinate pretty quickly. So let's say points.sort, and I could by default sort based on the X coordinate, but I want to sort based on Y coordinate, so if I just use a key equals lambda x, where lambda x is officially x bracket 1, x bracket 0, I think that's the syntax. Sort key lambda. Key equals lambda x expression. Okay, yeah. So this is gonna, for every element in the array, treat the element as a tuple that is the second element first, and then the first element second. So yx rather than xy. Maybe it's better to use p rather than x just to make it clear. It's just referring to the point. So sorting based on the y coordinate, then at that point I don't need to use the prediction. I can use while loop. While n is the length of points. I guess I can use a for loop, maybe. I'm iterating through the point indices. I only recalculate based on if there was a change from the previous y coordinate. I guess. So use for every index in range n, in range 1 to n. I think I set up a dummy one so that I don't go out of bounds with the references to index -1 here. So I'm going to do points.append, let's say infinity. I guess these are arrays, or whatever. You can pair elements within those things anyways. So I think I need a running total. So streak is going to equal 0. If the current x coordinate, if the current y coordinate matches, so if points at this index, the y coordinate equals points at index -1, the y coordinate, then it's just streak increments. Else the streak is going to have to reset. And when it resets, eventually I'm going to say streak is back to 1. And I need to calculate the other stuff. So total equals 0, ans equals 0. So the current streak needs to change. Current streak is basically the sides here. Yeah, sides here. So I guess if the current streak is equal to 1 or less than 1, then don't do this put here. So I guess maybe if the only thing here is if the streak is greater than 1, then the number of sides on this 5 point is going to be streak times streak -1 all over 2. And then answer increases by streak times the previous total. Mod and then the total increases by the number of sides at this level. And then that all occurs. And then I have I think maybe I'm going to actually go to n+1. so that actually does the last little bit, comparing the last streak, possibly. Okay. Return answer. What errors did I make? Errors of logic, it looks like. 6. So it's calculating too much. I wonder if I should have only n. Yeah, it gives me 0. Okay. So 6 and 2 rather than 3 and 1. So the points match. So if the points match the y coordinate, then it has to be 2 points in the same. 2 points. I see. If these things match, then it should actually be. No, that's right. So it becomes streak equals 2. If it's already 1 at the start. I think I should start with streak equals. No. Let me think. So if it's a new streak, then that's the first point at that y coordinate. So streak should equal 1 at that point. And then the next time y coordinate's the same, and streak increases to 2. Or if you have a y coordinate that's different, then streak goes back to 1. Okay. So let's say it goes to 2, and then the next one it says a different thing. So it goes 2 times 2 minus 1 divided by 2 is 1. I never declared sides. I guess it's fine since it's declared here. Okay. Total increases by the number of sides. Okay. I guess maybe I just need to print out some stuff here. Print out points. So 0, 0, 0, 2, 2. So it's like 3 and 2. Okay. I'm going to go ahead and print it right here, streak and sides. So it should say 3 and 3, 3, 2, 1. That's actually right. That should be 3 times 1. Oh my god. I'm so bad. Ugh. Ugh. Just couldn't copy and paste correctly. Couldn't copy and paste my logic. Yeah, it should be sides rather than this current streak. Alright, let's see how fast this is, or how slow this is. Okay, yeah, sorting it wouldn't have made sense for it to be faster. But who knows? Yeah, so let's go back. Go back to this. How do I make this faster? I mean, Maybe there's some base case that I should work with. Base case that I should do here, points is 4 points. There's going to be at least 4 of them. Okay. Every y values are going to be very large. Possibly. So number of horizontal trapezoids. Every y coordinate. So I have to go through all the points to figure out how many x coordinates match with a particular y coordinate. So that should be pretty fast. And then for every y coordinate, you know what? I think maybe this might be just slow because of the decomposition of all these variables. I think maybe if I didn't do that, then this would be faster. So x count equals 1. I don't know if this is even necessary, because then if x count is 1, then this is going to get to 0. Alright, let's go ahead and try it. So sides equals I think I'm pretty sure I need this variable. So sides equals the x count set this y. I'll just say it's y. Times x counts of this y minus 1 divided by 2. Answer equals answer plus sides times total mod total increments by the sides. Okay, yeah, I think this still works. It should be sides. Oh, yeah, that should be sides. What the heck, man? It's even slower. What? Ain't no way. What? Random. Oh my god. Alright, there's something seriously wrong with this Python speed testing. There's just no way that this is slower than the previous. Well, I guess maybe. Okay, if x counts at y equals 1, then skip it. Maybe that it does skip over some set of executions. I guess it does skip over a lot of possible points. Alright, let's think about this. So if the count there is 1, then skip it. The number of sides is tabulated. The sides is tabulated. And then the total is increased. Man, that seems so concise. How would you optimize further than that? Default dictionary, the total, an answer, the for each loop, skip over the trivial y values, you calculate the sides, and you have to calculate the sides, otherwise you don't know how much you increase the total by. I wonder if there's something here. I wonder if I can do some sort of counter. No. Okay, I kind of give up. So I think this is going to be, I don't know why it's slower than the previous ones. Bunch of slower submissions. 79 milliseconds, 83 milliseconds. No, whatever. I'm done. Alright, summary. So this is going to be math computation problem. So every trapezoid is the combination, forms by combination of two horizontal sides, where those sides will have unique y coordinates. Otherwise, it'd be impossible. Otherwise, they'd be not non-horizontal or on the same kind of or collinear, I guess. It'd just be a single line. So how to quickly determine the number of combinations, which would be equal to, like, for each count at a y coordinate for each horizontal side, count at a y coordinate, pair that with the horizontal side count at a different y coordinate. Use a default dictionary to track the number of x points, which is the count. Or that's not the side count, it's just the x points. X point counts at a y coordinate. From the x points for y, determine the number of horizontal sides that can be formed. So if the x count is 1, then the sides is going to be 1, or 0 actually. You can't form any sides with just one x coordinate. If the x count is 2, then the number of sides there would be 1. If the x count is 3, then the number of sides there would be 3. And in general, n would lead to n times n minus 1 over 2. Yeah. And then iterate over then keep a running total of the side counts at each level. By level I mean the y coordinate. Determine the number of sides based on the x counts. Increase answer by that count, the current count, times the total, and then increase the total by the sides, which is the current count, yes. Alright, time complexity, this is going to be O of n to generate the x point counts for each y, and a quicker loop to determine the answer based on that, based on the dictionary of counts. Base complexity, this should be O of n to keep the default dictionary of counts. So pretty straightforward. I just don't know how to optimize it faster than what I see on the thing. Anyways.